Critical thinking rule 18. Causal arguments start with correlations. Rule 18 says that causal arguments start with correlations. A correlation is a relation between two factors where the value of one factor predicts or gives you information about the value of another factor. An example of a correlation is students who attend class regularly receive higher grades. This is asserting a positive correlation between classroom attendance and how high your grade is. The higher your grade is, the more we would expect you to attend class regularly, and vice versa. Correlation is a necessary condition for causation, or a causal relation between two factors. That means that in order for there to be a cause-effect relation, for example, between attending class and getting a good grade, there has to at minimum be a correlation. So correlation is necessary for causation. However, correlation is not a sufficient condition for causation. That means that some things can be correlated with each other, but not such that one causes the other. Correlation just means that the value of one factor lets you predict the value of another. But sometimes things can vary together even when one does not cause the other. And some correlations are coincidental, as we'll discuss later. First, let's talk a bit more about what correlations are and the types of correlations. To begin with, let's distinguish correlations from non-correlations. If you say there's no correlation between two factors, x and y, that means the value of x is not dependent upon the value of y, and vice versa. This is also phrased as x and y vary independently of each other. An example is the value of the stock market and who's the Major League Baseball champion in a given year. If you know the value of one of those, that does not help you predict the other. So there's no correlation between them. They vary independently of each other. A positive correlation between two factors x and y means that they both increase together or that they both decrease together. When x increases, y increases. When x decreases, y also decreases. An example of a positive or direct correlation is being a philosophy major and having a high GRE score. GRE is the graduate record exam that you need to take to go to grad school. As you can see from the diagram on the right, between the years 2015 and 2018, philosophy majors had the highest mean for all three sections of the GRE. A negative correlation between x and y means that they vary inversely or negatively with each other. When one increases, the other decreases, and vice versa. An example is the vaccination rate and the rate of disease in a population. The higher the number of people that are vaccinated, the lower the disease rate is going to be. This example also shows you the relation between correlation and causation. So in the case of vaccination, we suspect or know that being vaccinated is the cause for being less likely to get the disease. So there is a causal relation between vaccination and not getting the disease in the case of this negative correlation. In terms of the other example of the positive correlation between being a philosophy major and getting a high GRE score, it's actually less clear if that's a causal relation or not. So keep in mind, this is about the difference between correlation and causation. Correlation means the two factors go together. So if you know someone is a philosophy major, you can predict that they'll have a high GRE score. However, this does not prove that being a philosophy major causes you to have a higher GRE score. It's also possible, for example, that people who would do better on the GRE anyway, because they have better verbal or quantitative skills, also happen to be more likely to choose a philosophy major. So there's various types of correlations between things, whether positive or negative, that don't have an actual causal relationship. There could be, for example, some third factor that both makes people more likely to choose philosophy major and helps them do better on the GRE. Here's an example of a causal argument that starts with the correlation. Students who attend class regularly receive higher grades. Therefore, attending class regularly will increase your grade. This has one premise, and then the next sentence is the conclusion as indicated by the word therefore. So where's the correlation? We can see the correlation in the premise. Students who attend class regularly receive higher grades. This is asserting only a correlation between attending class and the higher grade. It's saying that if you know someone attends class regularly, you can predict they're going to attain a higher grade. However, this is distinct from causation, and this can be a very subtle thing to detect. You have to pay attention carefully to the wording of a statement or a proposition. In the conclusion, it says attending class regularly will increase your grade. The change of verb from receive to increase is asserting causation here. It's implying that attending class regularly does not only correlate with getting a high grade, it's the cause for your grade increasing. And so this argument is starting with a correlation in line 1 and then moving to a causal claim in line 2. Notice that this argument is actually not that effective. Correlation alone does not prove causation, because it could be that there's a third factor, for example, that causes people both to attend regularly and to have high grades. Maybe if they're highly interested or motivated, they will do both, and it's not the attendance that's increasing their grade per se. Next up, Rule 19. Correlations may have alternate explanations.